Hi, I'm Dan Klimke. I'm the product manager for OptiView at Fluke Networks, here with
Zach Belcher, product manager for TruView. And what we're going to take a look at now is a demonstration of both the XG and TruView as well. We'll walk through a couple of scenarios to start with inside of TruView just to get a feel for what the product is, what it does, and we'll troubleshoot a couple of problems. We'll do a network problem, we'll do an application problem, and then we're also going to take a look at the integration between the two solutions, how we'll use those two together to do path analysis and really drill in on a problem that a particular user is having.
Sorry,
So,
did you hit F9?
Oh,
There we go.
so to start with, what we'll take a look at is a network performance problem. So we're inside of TruView now. Again, it's a web UI that brings together all these different data sources. And you guys are going to be experts on how to use the product by the end of this session, because really all you need to know to start with is type in what you're looking for up on the search bar here. So I've had users complaining of poor performance at a particular location, in this case, Madrid. So I'm going to type in what I'm looking for, and I get back that I have a site called Madrid, I have the router that's in Madrid, and I have the WAN interface in Madrid. I want to look at the overall performance of the site, so I'm going to start by clicking on the site. What's loading up now is a pre-built page. And when I say pre-built, I mean I didn't build this. The product does this automatically. So this isn't a bunch of magic that we put together for a demonstration where, hey, put this thing next to this other thing. This comes out of the box like this for any sites that we're monitoring. We always start with what is the response time? How slow is it for the users? So that's the first view that we're going to take a look at, is what is the response time for this location? Here we can see if we mouse over before the big spike happened, my network round trip time, that's the purple color, comes up at about 38 milliseconds. As I look during my performance issue, I can actually see my network round trip is about 100 milliseconds, and my data transfer time, think about the difference between one round trip of the network and, hey, someone's downloading something, that's going to be a lot of round trips, right? The data transfer time is 300 milliseconds now. So the network is slowing down. I have proof of that this time. I don't have to feign ignorance on this one. I'm going to actually have to troubleshoot this. So as we scroll down, what we're going to see is the relevant information we need to troubleshoot a network performance issue. What's the utilization for the WAN links at this location? I can see that here because, again, we're putting these things together and we're not separating those out and saying, go look at SNMP now. Here's the utilization of this link. In this case, I see there's a utilization spike that corresponds during that time frame. I want to know what that traffic is. That's as simple as flipping over into application view, and now I'm looking at the net flow data for that time frame. That is, of course, is going to lead me to what is it that's causing that big spike in utilization. And in this case, it's not something that's business critical, because that would be very different. If we saw some traffic on here that was a business critical application, oh my gosh, we don't have enough bandwidth. Here I see that this is people going to the internet, watching some YouTube links. That stuff we can police out. We can do QoS to deprioritize it, or we can, scold our fingers at some users and say, don't do that, cut it out, right? We send them a scary email. Whatever the case is. As I scroll down, I also get more detailed breakdown of just here's the overall top apps, and here's the conversations as well. But the idea is really within a single click, I've got the data I need to identify what's going on. I talked before about having all the NetFlow data and being able to get really granular. If I want to see every little detail, I can actually drill into the link itself and see everything about that link. But at this point, I've probably got what I needed to at least troubleshoot this kind of top-end problem, right? I can see it bubbling up at the top. But if we go into the NetFlow data, this is where we can get into all of that raw NetFlow that I talked about before, and we can start to see thousands and thousands of hosts, conversations, protocols, everything that's happening on those particular links. But in this case, oops, sorry, that's ERP, I can see exactly who's talking on YouTube. Here's the top hosts. I can see they all spiked up about the same time because we have these great little preview graphs, the little spark lines here. So I already know that actually all of these hosts were doing this at this time. Looks like someone shared out a funny video and everybody's clicking the link together, right? That would never happen. Not during work hours. Come on, Zach. This is unrealistic.
So can you tell who did it first?
If we drill in close enough, yeah. Well, it's NetFlow. We're limited to 1 minute granularity, right? But in theory, we might see one person start before the others, right? So that kind of walks through an example network troubleshooting scenario. Does that make sense? Any questions on that? Okay, let's move on to the. Oh yeah.
can you dig in any further than in that YouTube example, right? Like, so can you find the URL? I mean, if you're catching all the packets going by, wouldn't you see the...
Only if we're spanned to where that was going, right? So this is coming from NetFlow. So this is actually literally a view from that WAN router at that remote site.
Right.
The span would be done in the data center, typically. Now, we do have options that can do remote packet collection as well, but for this, the typical deployment will be in the data center. So if we were getting a span, exactly, we are now drilled into just NetFlow because that's what I clicked on the interface. I'm looking at that interface as NetFlow data. But if you had spanned us that traffic, there's also a similar view of any data that we got spanned. So we can build the same view for spanned data as we do for NetFlow data. And then you actually could extract the packets and see the URLs.
Now, can we customize that view to bring in other related data? So, for example, let's say we're running proxy services and caching services and we're logging that to the nth degree. Can we customize that view to say, oh, by the way, not only is this guy going to YouTube, but according to the log data from the proxy server, it was that guy in that desk.
Yeah. So one of the things that's really nice about this web UI is if we go back to some of the dashboard pages, I don't know if I showed this briefly at the start, this is a drag and drop interface at this point. I had drilled into a couple of workflows, right? Those are pre-built and it's kind of, this. These dashboard pages, you have the option to add in third-party URLs to here. So we can put in a little iframe, and if you've got some data on some other system, maybe whether it's log stuff or maybe you've got things from your F5, whatever it is, you can give us that URL from that other monitoring system and we'll paste that view right next to the other. So you can absolutely build a dashboard that combines our data with things from other tools or other sources of information. And it's similar on the other side. We can also export URLs very easily. If you want to paste our data somewhere else, we've got an API for that.
Now, can we pass time signatures to those requests?
Pass time signatures. I guess follow up with me on that one and we can get a little bit more specific. Let's see if I can do that.
This interface seems pretty responsive. So can you talk to us about where is the data that you're looking at right now getting pulled from? Is this all web interface and database on one appliance?
So it does depend a little bit on which data we're looking at. The raw flow data, if you're in a distributed environment, right? If it's an all-in-one appliance, everything's on the one, right? So that one's easy. But if it's a distributed environment, like I talked about before, where you've got that centralized manager, the raw flows and, of course, raw packets would be stored on collection devices. So once I get down to that point, I'm absolutely going into the actual device. Everything you've seen so far, though, would have been on the manager because everything there was higher level, 1 minute, summarized data. The only things that stay down on the boxes, if you will, stay down on the collection devices are some of the raw flows and raw packets and raw transaction level detail. And we'll see a little bit of that transaction detail in a moment. And that'll compare and contrast. And you'll see it will take longer to load a transaction level detail.
What happens when I've got multiple terabytes of stored data and I need to populate a page like this? Does it get longer to load the page the more data I've got?
The more data, it'll get a little bit slower. Yeah, it absolutely depends on the load of the system. But this is I would say this is pretty standard for these dashboard level pages. And if anything, I sometimes complain the demo is a little slow though. So it entirely depends on your deployment, but you're not going to be waiting for hours for this page to render. The things that would be slow.
What we're looking at here is a pretty typical response time for production environments.
Yeah, I was on a POC last week for a customer. Not POC, sorry. I was on an installation. It was actually a production installation last week, getting the customer set up, and if anything, it was a little bit faster than this. Because I'm on a hotel wireless here, right, going out to the internet, and I got a little bit of front end slowness here.
I was going to ask, I see up in the corner there something that looks kind of like a user identification. Is there some sort of like user-based, access control type stuff? Can you build views for certain subsets of users so that branch administrators can just see stuff affecting their branch or something like that?
The checks in the mail. You're awesome. Yes. I'm going to bring you to my next presentation. Yes.
I'm a great show.
Awesome. He's a plant. Absolutely. So if you've got someone who's only responsible for sites on the East Coast, you can build him as an East Coast engineer, and when he logs in, those are the only things he sees are those routers he's responsible for. You've got a manager, limit him to just some high-level status dashboards.
Yeah.
We're going there. Yeah. Right, we can go there. We can go.
You don't actually want live data for that, though. You just want a big
It just has a JPEG. Yeah, it's just a big JPEG.
green circle.
So there's your circles, right, on a map, right? Hey, look, it's good. So you can absolutely do that kind of stuff.
And can you tie that into a directory of some sort, like a Radius or LDAP?
Absolutely, yep. Radius integration, absolutely.
So are there any latency requirements between your collectors and the manager, I guess it is?
I'm not aware of any latency requirements. We haven't hit anybody they're way too far out of sync. If you ever lose communication between the two boxes, they'll just resume it as soon as it comes back up. There's no data loss and that kind of a situation. So that, to me, would say, as long as they can talk and eventually get the data there, the only delay would be, hey, if you're expecting, if for some reason it takes 5 minutes to send a file between the two systems, we're not going to have up-to-the-minute data, right? If you're on some 56K link in South Africa or something like that, it might take a while. But no, I'm not aware of any that says, we just won't function if you don't have this much. Great questions. Oh, I wanted to show you guys something really cool. I want to show you what we can do on the layer 7 side, to your question earlier. We have an application issue, right? Where do we go? We always start with a search bar. I'm going to type in the name of the app that I'm interested in. In this case, I'm looking at our ERP application. And I can see it's got a couple of tiers to it. I might be hinting at something there that might come up later. But let's start by looking at the web front end. So as I drill into the web front end, now the hotel wires is slowing down. Did I click? I did, okay. Again, we're going to be taken to a pre-built page for this particular application. This is now part of our application-based workflow. And you can see the page is a little bit different. We start with the end user response time again. But in this case, down below, I have a view of how many transactions there have been, because that could be an indication of load, right? Is the server slower because there's more transactions? Is it doing more stuff? So, two things to notice. Well, this is actually the issue we just troubleshot a second ago. This is the one that was going on in Madrid, so that's why I see that big data transfer time. So I already know what that is. Here I see this big spike in the blue color, and that's our application response time. And I don't see that big spike in the purple here. So that's a time frame I want to focus in on. The other thing I didn't mention before, this gray line represents, I talked about baselining. That's called our TPI, typical performance indicator. And we do the same thing down here on the transaction graph. What's the normal amount of transactions? So we see transactions went up a little bit, app response time went up a lot a bit. What I'm going to do now is something that is unique to our product. I'm going to go ahead and click on this view of transactions, and to your point, I'm now going out to the individual collection device and saying, show me the transactions that happened during that time frame. So gone is the world of averages. We're not dealing with here's the average response time anymore. I'm now loading up every single individual request that was made to this server. In this case, I've got 3,000 requests in the 1 minute that I was looking at. And these numbers will get massive, right? Very, very large database potentially, to your point. Here I'm seeing that I've got it sorted by slowest, so I'm going to see the highest numbers first. This individual GET request took 52 seconds. If I want to find out more about that, I can go over to our transaction detail. So right away I'm able to tell, I don't think this is a network issue. But now I've got some information that I could potentially hand off to my application team to say, here's where you should focus your attention. Here's what we're seeing from the network is huge application response time, small requests. I can see how many bytes and how many packets were going back and forth. No TCP conditions. I don't have any retransmissions. I don't have any zero windows or out of order packets. And here's what the user requested, and here's what the response was. If that's not enough, I can absolutely give you the trace file for it as well, because we're streaming all of these packets to disk. And so that's the difference in workflow that we're taking. We still have packets, but we don't want you to sift through hundreds of megabytes of filter, try to find something weird, hit filter, wait 3 minutes for the thing to re-render. We've all done that before, right? How about we just take you to the one thing that's slow and give you a capture of just that? That's a much different troubleshooting workflow when it talks about going to packets. Now,
And I assume that you're able to apply filters, so you're able to correlate flows that are related in the form of like an FTP control and then data session or a SIP call set up in the related RTP.
So what you can do when you go to transaction detail and export to package, you can do either just that one transaction or you can do that entire conversation, right? So you'll see everything that those two hosts were saying to each other instead of just, here's this, you'll see the whole session set up to tear down instead of just that one initial one. For FTP, where you've got a control session, you may have to open both apps. I haven't tried it. I don't know off the top of my head on that one. Okay, So one other thing I'll show, we also can do encompass transactions, show you the database queries during that one. Running a little low on time, so I'll keep it relatively quick, but same idea. You can get the details off that and see, hey, it's actually a 14-second database query. That's our problem here. We've had some great questions, so I apologize for going fast on this part. I will show you one last thing, and this is the integration. Something that we have that is unique. I'm now going to type in a username. So this is the login name for this person, A. Patel. I'm going to pull back their IP address, and now I can look at the performance of an individual user instead of looking at a site or an application. And the reason we do this is to tell you, is this user's performance different than the rest of the site? Are they doing something abnormal? Do they have high utilization? Do they have high response time? And then we're also going to give you that option to drill in with the XG that we talked about earlier to trace the path to that user. Okay. No, my demo system.
I can actually see that being extremely useful.
Exactly, because when a user calls up, all right, what's your IP address? No, go to command prompt. Okay, forget that. Just go to the start menu, type in CMD. Yeah, lots of fun, right?
Well, I mean, I had a situation a few weeks ago, users, everything was normal, everything was identical to anything else, but as it turns out, they fired up an SSL VPN in the finance department to connect to the bank system they need to get to. Everything was being bounced out that. Coming back with hundreds of milliseconds, literally, of latency, and they were wondering why our in-house system was so slow.
Because they weren't going to it directly. There you go, absolutely. So I'll go relatively quick. I would normally spend a little more time on the difference between this user and the rest of the site's performance, but suffice to say, this user is way slower than everybody else. What I can do is actually pick one of the applications we're monitoring and do a path analysis to that user. And we'll start actually tracing the path to that user and polling every hop along that path to tell you at 30-second granularity exactly what's going on along every hop along that path. This is something I would normally pick what type of path I want to run and then start it, but I've actually already kicked one off earlier, so I don't want to wait for it to populate data. I'm just going to pull one up that I've already got running. And it's to that same user, because I knew he was having problems. And what I see right away on this path is here's all the hops, and I can see I've got some red X's going on, and that's because I've got errors occurring on these links. Why is that occurring? Well, our little arrow indicators, what do you think those indicate? And how come this one's not two dark colors, this one's got a light arrow? What do you think that might mean? How much fun would that be to isolate down? I mean, we'll get there eventually, right? But is that where we would have started? Right? It saves us a little bit of time, and we're trending these over time, right? We're now doing a 30-second granularity test, S&MP poll for as long as we run this test for us. We can keep this running. This doesn't have to be a temporary thing. We absolutely recommend picking some critical sites and leave that XG running, like Dan was saying, constantly doing tests out to those critical sites so that you understand what's going on along every hop.
How are you doing the L2 trace there? Are you pulling cam tables and from SNMP? Or?
Yeah, it's our own proprietary algorithm of the MAC tables, ARC tables, and route tables for layer 3, as well as doing a trace route.
And you're just reading them down until
That's
you have
correct.
weakness?
That's right. And then we're looking at each interface on each device, and as Zach said, pulling it at 30-second intervals. And this is a key difference in what a lot of people are looking at OptiView, looking at some of their network management system and saying, well, what's the difference? And the difference is that polling interval when troubleshooting. Right? An 8, 10-minute, 15-minute interval is fine for network monitoring, network management, but what happens inside that is going to be revealed with this granular slice.
Well, that addresses something else I've been seeing with a lot of tools, which is I'm a fan of people monitoring every interface, because if you check for errors, you'll spot your duplex errors, duplex problems, and some other problems like discards and oversubscription. Problem is that the licensing on a lot of products is per interface, and with some relatively inexpensive products, that makes it unaffordable.
I can't help but look at this and just think that the data and the views here would be nice to identify DDoS or malware outbreaks, or there's so much that you can use it as a security tool for, without even having to say, hey, somebody has a problem, let me see what the problem is. I could just...
Yeah, and there's absolutely, as Dan's getting set up here, in that net flow data, we have a couple of views to say who's doing fan out, who's talking to the most other hosts. We have some abnormal host behavior trends as well. It's not our primary use case, but to your point, security folks still find it useful, absolutely.
What options are in there for sort of proactive alerting of troublesome applications? Can you select certain ones that you want to flag, or is it just sort of everything at once?
You can control how much we monitor, if we just do response time, if we do transaction storage, if we just do volume statistics, and then you can choose a level of alerting. We'll calculate those baselines, let you know when it's abnormal, send a trap, an SMS text message, a syslog, whatever it is, right? An email.
Real quickly, I wanted to pop over to the OptiView XG user interface, dashboard-oriented. Key to your point, too, is the monitoring of switch and router health. So if that duplex mismatch, that occurred in the past sometime, that's going to show up as an FCS error. So we're monitoring each individual switch port everywhere across the network for those proactively, so that we don't have to wait for the problem, and then as Zach said, we go find the problem. We would have been notified of that problem initially. Our network discovery, of course, we go out and discover all subnets, all devices, start categorizing devices and where they're located. And from that, logically then, we're able to generate a network map, instantaneous network map for how the network is laid out and architected as it is today. And this is also somewhat interactive. I can use, I can do some visual troubleshooting and see what's happening on these devices, where am I connected. I can generate inventory reports from here too. And then the path analysis that Zach saw on the on TruView is also available to be run on the OptiView. But of note, I wanted to just pass back over to this end user response time. This is the integration from TruView into the OptiView XG, where we're able to utilize that data, same kind of mode, where I have a particular user who's complaining of a particular problem. We already know what site they're from. We're going to pick the application of interest. One more. Oh, too far.
Sensitive mouse.
And we get that data sourced from TruView that tells me, okay, this user at this site is experiencing about twice the end user response time from everyone else in the site. Of note is this application, the end user response time heat chart, that the bullseye is telling me this is a network issue. This is not anything to do with an application. And if I were to drill in on the details, just flip the chart, I can see that retransmissions are off the chart. Evidence of that duplex mismatch problem, drop frames resulting in retransmissions. I think we're at the end of our time. I just wanted to say thank you very much for the time and the great questions that you had. We appreciate the opportunity and your feedback, and thank you very much for being here. Okay.
Thank you.